Hello, my name is Moses Ajay. In this presentation, I'm going to be covering descriptive statistics and significant testing. Now, at the end of this presentation, you should be able to apply descriptive statistics, t-test, and chi-square test in data analysis. Now, what is descriptive statistics? Now, the whole essence of having statistics is to speed up and simplify interpretation and compression of data. Sometimes data can be very useless, but by the time we analyze the data, we begin to find meanings from our data, begin to make them more valuable to us. Now, and there are two types. Now, the very first one is we can use our descriptive statistics to organize data, and we can also use it to summarize data. When it is used to organize data, you will agree with me, this is going to be very easy to do. It's going to be very easy for us to understand what we mean. Now, for example, we can have numbers that you put in a table. You can put them in tables, in a graph. So when you have somebody looking at that, now you make the data more meaningful to them. Another thing we could use the data to do, we could use descriptive statistics to do, is to summarize data, which we include using it to measure the mean, the median, the mode. Then we can also use it to measure dispersion, talking about the range, variance, and standard deviation. All of this will make sure that it's all about making sure that our data are meaningful to us. We can make sense out of it. If we just have numbers of the mass, for example, if we have a product, you have in your company, and the machine is taking measurement of each of the product that leaves your company, and you just have all the numbers, 4.2, 4.5, 4.7, 5.1, and so on and so forth. And you just have the numbers everywhere, and it doesn't make any sense to us. By the time we begin to organize this data into tables, into graph, or perhaps we find the means, the median, the mode, now it begins to make sense to us. Now that's the whole essence of descriptive statistics. And in this presentation, we'll be looking at two different types of data. We have the population data, we have the sample data. Now, I want you to know the difference between the two. Now, when you're talking about population data, you're talking about all the data. For example, it might be total daily production, or it might be total monthly or yearly production. And sometimes in statistics, it's very difficult for us to work with all the total production, because, for example, some of the tests you'll be doing, for example, might be destructive, and you don't want to destroy all your products in order to drive home your point. Now, we may want to go for samples. Let's go, maybe, for example, we might say out of 100 products, we can say, okay, let's just work on 10 or even less than that, depending on the value of the product. And some tests are not destructive, and because of that, we may want to say, okay, let's use the entire data. But sometimes it might be very difficult to use the entire data, because it might involve a lot of computation, a lot of analysis, and so on and so forth. So that's the whole essence of having sample data, just to pick samples from the entire population. And something I want us to know is the difference between the two in the computation of their variance. If you have your population variance, now you can look at the difference between the two. Now now here we have population variance, we have sample variance. Now these are the formulas. Now you could see that in your population variance, your n is your denominator here is n, and your denominator here is n minus 1. Same as population standard deviation. Here is n, and here is n minus 1. So I want you to please take note of the difference between the two formula. Now, when you are working with sample data, please take note and ensure that you use a formula for formula for population. And when you are using when you have access to sample data, please make sure that you use a formula for sample data. Now, I think it's going to be very good for us to have some examples. Now, we have means. It's just the common mean that we have, summation of all the values, then divide by the numbers of items. And then, like I said, we have our sample standard deviation, and we have our variance, which equals the square. Our variance is the square of the standard deviation. Once you have your standard deviation, to get your variance, find the square of your standard deviation. So it's important for us. If we don't get our standard deviation right, that will affect the answer for our variance. So we just have to take note of that. So once your variance is, once your standard deviation is correct, you will definitely get your variance by finding the square of that. So I think let's just look at some this example. So we have a set of number 5, 4, 5, 3, and 4. This might be something that we've read from the products. Maybe the first product is 5 grams, the second product is 4 grams, the next one is 5 grams, the third one is 3 grams, and the fourth one is 3 grams, and the last one is 4 grams. So we want to find the mean. So to find the mean is just summing them together and then dividing it by the numbers of items. The numbers of items here is 1, 2, 3, 4, 5. So n is 5, and then we sum them together, then we have our mean to be 4.2. Now for mode is the numbers with the highest frequency. In some situation we have like in this scenario, for example, this is a very, very good example. We have 4 is appearing twice and 5 is appearing twice. So this is a bimodal data. So we have our mode to be 4 and 5. Most is will be 4 and 5. Now to find the median, you need to arrange them in the order of you can arrange them in the ascending order or descending order. So let's arrange them in ascending order: 3, 4, 4, 5, 5. So the middle number is your median. Now we know there are 5 items, so you first of all cast the first 2, so and then last 2, then you know that our middle number is 4, which is the median. Now for standard deviation, you need to do a bit of calculation here. Now for us to know our standard deviation, we need to find our mean. Unfortunately, we've done that before. Now what this formula is saying is that you will be taking each item, you'll be taking the mean from each of the item, then square that, then you can see the sign saying summation. Then you need to be adding them together and then divide it, because we assume this is a sample data. It's a sample data, so that is why we are using n-1 in our denominator. So let's do this together. So our standard deviation will be, now if you look at the first item 5, so we take away the mean, 5 minus 4.2, then we square that. Now because of this the symbol here, summation, so plus 4, that's the next item, minus 4.2, then square that. 5, the next item, minus 4.2, square that, plus 3 minus 4.2, which is the mean, square that, plus 4 minus 4.2, with this 4 here, the last item, minus 4.2, which is the mean, square that. Then divided by n-1, which is 5 minus 1. So we solve that, we simplify that, and we have this. So for this 0.64 is standing for 5 minus 4.2 square, and so on and so forth for the rest items. Then we have divided by 4. Then we have our standard deviation to be 2.8, square root of 2.8 divided by 4. And then our standard deviation is 0.8366. And to find our variance, we know that our variance is the square of our standard deviation. And when you do that, when you square this, you have your variance to be 0.7. So don't be afraid by seeing this to be 0.7 lower than this, because of this is in decimal place. When you square 0.83666, you will get 0.7.